Okay, good afternoon everyone. Welcome to Epinic eLearning web class. We will be doing routing basic today. So in the routing basic presentation, what we'll be doing, just the basic concept that you need to learn before you go into further detail of the routing technology. Okay, so let's move on. As an introduction, my name is Nurul Islam Roman. I am currently the senior training specialist in Epinic. I'm in Epinic since 2006. Initially, I used to be the host master, then I moved into our development and learning and development team. As you can see on that slide, I have got some interest on those topics listed. So yes, if you have any question, please raise your hand and ask your question on the topic today. And also, at the end of the presentation, I will show you an URL. So using that URL, you can send us some feedback. Your feedback is very valuable for us because based on your feedback, we will try to improve our future e-learning session. Okay. And last but not the least, acknowledgement to Cisco system. So when we develop the routing content, we actually used Cisco's some of the Cisco's materials as a reference. So thanks to Cisco system for that. So here is the overview what we are going to do today. We'll try to explain you what normally a router do or does, and then we'll try to sort of differentiate between the function of routing and forwarding. Okay. Some people might consider routing and forwarding is almost same thing, but to be precise and to go further detail, we really need to sort of distinguish the difference between routing and forwarding. That we'll be discussing today. Then very fundamental routing principle, how router does the routing table lookup, right? And obviously the longest prefix match, how those longest prefix match function works, we'll explain those. Then we'll explain what is RIB, routing information base, and what is FIB, forwarding information base. Okay. Then we'll explain the explicit routing and what is default routing. Some places why we use default routing, and in some places why we should use explicit routing. We'll explain those things. Then autonomous system, which is the building block of internet. We'll try to explain what is an autonomous system on the definition level, right? And what you need to build an autonomous system, we will explain. Then we'll cover a little bit of routing policy. What does it mean by routing policy and how you can influence those routing policies. Towards the end, we'll explain what are the routing protocol that we have as an option, and we'll try to sort of classify them into IGP and EGP class. Okay, so those are the overview that we have for today. Okay, let's move on. So what does the router do? We all know that. So they normally find path, right? So in the internet or in IP network context, when a packet has been created by the source and machine and to send it to the destination site, so those packets, a very small chunk of the data usually comes to the router, and routers sort of look into the header part of those packets, and based on that, they try to do the routing table lookup, and from there they try to forward the packet. So that's what we call finding the path, right? So when they do the routing table lookup, that routing table need to be built before, right? And then the router will be able to send the packet across. So how the router will build the routing table, that function that we can call as finding path. So we'll explain those things. So this is what one of the main job of a router. So if you see internet, those are an interconnection of different networks, right? So each networks might have one or more than one routers, and those routers interconnect the other routers, and this is how those small networks are interconnected. So obviously when the packet comes from the machine to the router, router knows with whom he is connected to, right? Or it is connected to, and based on that connectivity system or architecture, they learn the destination information, and when they forward the packet, they look into the destination information and keep forwarding the packet. So this is how a router first learn or find the path and then keep forwarding packet, right? And again, router need to find alternate path because at one point of time, the network topology can be changed. It could be for some reason like breaking of the cable or changing the topology, right, based on some other factor that we have. So when those topology will be changed into the network, the router job is to find the alternate path, right, to forward the packet across, and then afterward the router keep forwarding the packet. So this is what a job of a router: finding the path, forwarding the packet, and then find the alternate path if the topology is changed, and then keep forwarding the packet. So this is what router normally does until you power it off. Okay. So routing versus forwarding. What is routing and what is forwarding? So normally, if you look into routing, the terminology itself is self-explanatory. It explains how router build the map. That's what we call routing function. So when a number of routers are interconnected, based on the interconnection, routers normally exchange some topology information, right? So when routers, they exchange the topology information, based on that topology information, router actually build their routing table. And when the routing table is built, right, then within this router, you might have a number of destination going through a number of interfaces, right? So within this router, router need to build a mapping between the destination and then outgoing interfaces, right? So this mapping inside the router actually considered as the forwarding table, right? So routing table is sort of a top level view, and from the top level view, routing table can tell you where is the next hop, right? And next hop can be an IP address, and then afterward, to go to the next hop, which interfaces router can use to send the packet across, actually the job of a forwarding table. Okay. So IP routing, finding the path. So how router, they normally find the path. Within the router, those interconnected routers, they actually run a protocol, right? We normally call them routing protocol. So by running a routing protocol, all those interconnected routers, they exchange some topology information, right? So by exchanging the topology information using a routing protocol, they can learn a single path to a destination or more than one path to the same destination. So when a router, they learn a single path to a destination, then obviously this is the best path because it doesn't have any alternative. But in a case, if a router learn more than one path based on the connectivity topology, right, then the router's job is to find the best path, right? So to select the best path, definitely router need to look into a number of factors to select the best path. So those factors normally router consider to select the best path. If router has got more than one path to the same destination, we consider them metric. So as a metric, router can use a number of options, number of factors. Different routing protocol, they use different metrics, in combination of other factors. When router select the path or learn the path, as I said, those are based on a number of factors. It can be topology, it can be policy, it can be metric, right? And metric can include sometimes hop count, sometimes what are the filters they have, sometimes delay parameters, bandwidth, and so many factors. Okay, So yeah, based on all those, router they select the path. Routing lookup. How a router does the routing lookup. Okay, probably all of us are aware about the longest prefix match, or the IP prefix. We are familiar with that. So longest prefix match is if you consider IPv4 address, right? If you have got in the routing table, if your packet destination is some IP address, and if you see the network address that we have within the routing table, they'll have a sort of lookup within the routing table. And if for the same destination there are more than one subnet match, then obviously router will check the longest subnet as a best match, right? So this is what the very common principle, very basic principle of a router. I'll just explain in further detail. You see, in this topology, what we have 4 routers are connected. So we have got router 1, 2, 3, and 4. So router 1 is connected to router 2, and router 2 is connected to router 3 and router 4. Like this is what the topology. And if you see, router 3 has got a prefix which is 10/8. It's a long, it's a big prefix in here. And on the other side, router 4 has got another prefix 10.1/16. So theoretically, if you look into it, 10.1/16 is a small prefix that belongs to 10.8, which is a longer prefix, right? So when router 2 learned that path information from router 3 and 4, router 2 obviously knows to go to network 10/8. My destination is router 3, right? This is what is the routing table. And again, to go to 10.1, which is probably a small subnet of that big subnet, but to go to that subnet, there is a specific routers connected to router 2 as well, which is router 4, right? Then router 2 has got some other prefixes. So this is what a routing table that router 2 has got, right? Okay, now see, when a packet comes, the packet, IP packet, when it comes to the router 2 will have a look onto the IP packet header, and on the IP packet header, the packet destination is 10.1.1.1, right? So what router 2 will do, router 2 will try to do a routing table lookup, and when it performs the routing table lookup, what it has got already for that subnet 10/8, it will use that /8 subnet and do an AND operation with the destination IP address, right? And it will find out the network address and also the prefix that he has got 10 with the same subnet, right? And it will try to see whether that AND operation result with the destination IP address and whatever it has got on the routing table, does it match? Yes, it matches. So there is a match. Then again, it will check to the next prefix, right? And the next prefix, which is 10.1/16. So again, it will do the same operation, an AND operation with the subnet mask. So here, in this case, subnet mask is /16, right? So it will do another AND operation with the destination IP address and /16 subnet mask. And what is the AND result? AND result is same, right? So there is again a match. So now we'll have two match. One match for a /8 and other match is for a /16. Now the question is, which match will be the preferred match as a destination for the packet or as a next router or next hop for that packet? As I said, normally router, they will select the longest prefix as the best match. So in our case, /8 is a prefix and /16 is another prefix. So both the prefix has got a match. So and since the longest prefix match rule, router 2 will forward that packet to router 4 because the longest prefix match is /16, right? And other two prefixes like 20 and 30, it doesn't have any match. So that's why those will be discarded, when they'll take the decision. So this is what a very basic principle of a router when it does the routing function. All right, let's move on. Any question about that? So if you have any question, you don't need to wait till the end of the presentation. You can ask your question anytime on the chat box. I'll just try to keep my eye on so that if there's any question, I'll try to answer the question as quickly as I can. All right, so this is what the longest prefix match rule of a router. Now have a look, read and FIB. What is the routing information base and what is the forwarding information base? We have already explained routing function and forwarding function. Then we will see what is routing information base and what is forwarding information base. In the forwarding information base or in the forwarding table, what it contains the destination IP address or network and through which interface it will go to, right? So this is what contains on the forwarding table. So the router normally use this forwarding table when they will forward the packet from one side of the network to the other side. RIB on the other side or other hand, it also contains the list of the destination, but it maps with the various next hop. And next hop not necessarily can be an interface. Next hop can be another IP address, right? So in the routing table, what it contains, what is the destination and what is the next hop. And in the forwarding table, what it contains to reach to that particular next hop, what interface the router can use to send the packet to. So that's the difference between routing information base RIB and forwarding information base FIB. Okay. Now we'll discuss about explicit versus default routing. What is the explicit routing and what is the default routing? Let's define the default routing. Default routing means if you have got only one path to go to everywhere, right? So for example, from Australia, if you need to go to anywhere in the world, probably you can go to the Sydney airport. So for example, if this is the default path. So anywhere you want to go in the world, our default gateway is in Sydney. So if this is the case, do I need to learn every possible destination? Probably not, because wherever I go to the default route or default gateway, which is the airport, closest airport, right? So default route normally contains a single route or single routing information to go to everywhere in the world. So in the ISP scenario, if you have got only one upstream ISP, then in your router you can use that upstream ISP router interface as your default route, right? So that in your router you don't need to contain all possible destinations in the world, because as you know, currently there are around close to 500,000 plus it's 500,000 plus route available in the global routing table. So if you have a default route in your routing table, then probably you don't need to know all 500,000 plus prefixes into your routing table. You just have got one prefix, which is 0.0.0.0 in IPv4, right? And 0 colon 0 for IPv6. So this is what we call default routing. Default routing has got some upside and downside. What are the upside or advantages? Advantages of default routing is very simple, very cheap, because you can run a router that contains the default route in a very small routers. You don't need to have enough or huge memory, huge CPU process, right, or huge bandwidth. Just in a small router you can run your routing protocol. The disadvantage is low granularity. So you can't do destination specific traffic engineering, right? If your remote network is down, no way you can learn these things into your routing table, because your routing table contains only the default route. So if any route is down on the remote side, no way you can learn it. Explicit route. What is explicit route? Explicit route means on the router you'll have the whole routing table, right? Oh, there's a question. Well, the question is, can you please explain the relation between default routing and bandwidth? Well, when you have explicit route, right, you need, I mean, to import all those routes, you might need sort of a big band or high bandwidth compared to default route. In default route, you just have a single entry onto your router, and to exchange the routing table, your router will not consume any, probably sort of routing control packet will not sort of go through your expensive WAN bandwidth. That's what I mean by default and bandwidth, because default just set as an entry and there is no control packet going on in between your routers, right? So you can sort of reduce the bandwidth utilization, and most of the bandwidth can be used for your data plane. And in explicit route, right, your router with your upstream need to sort of exchange the control information for the routing protocol, right? And for that reason, definitely it will consume a little bit of or at a certain bandwidth for the control packet. So that's what I mean by default route and bandwidth and explicit route and bandwidth. Make sense? Okay. So in explicit route, the advantage is we can do destination specific routing, right? And also, like, if any of your remote network is down, that can be identified by your routers, and your router can dynamically change your path if the remote network is down. But the downside of explicit routing is, it consumes sort of high overhead. It's a bit complicated compared to default routing. You need expert people to manage the explicit routing that you have into your routers. It has got high cost in terms of management, and obviously it has got high granularity. So you can do destination specific traffic engineering. The third one is hybrid. Hybrid is somewhere in the middle. So you'll not have the explicit route, you'll not have only the default route. So what you have, probably you'll have the peering route, like, for the local route, what I mean by peering route, and the default. So whenever your traffic is going to the local destination, which is specific to the country or economy, right, you can do routing directly. Otherwise, if it is going to overseas, that can go through your transit circuits via the default route. So this is how normally the tier 3 ISP, they manage their network, right? Normally. There is another question. So please confirm, for bandwidth explicit routing is better. Well, it completely depending on your design, your topology. Sometimes if you need multi-homing, if you need redundancy, right, definitely you can consider for sort of a dynamic routing protocol running in between your upstream and your routers. So when you run those things, that will consume a little bit of bandwidth in terms of the control packet, right? So if you are sort of planning to do this sort of routing in between your upstream and your routers, definitely you have to use a little bit of internet bandwidth. Make sense? This one. And as I said, that decision is up to you how you want to do it, right? If you need to use a dynamic routing protocol, you need to keep in your mind it will consume some bandwidth as a control packet in between your upstream and your router. All right, so in hybrid, it will also minimize the overhead, and it provide useful granularity, not very high granularity, but a little bit of granularity it will provide, at least for your local traffic. And for hybrid routing, you need filtering knowledge. Otherwise, if you exchange route locally with the peer in the IX, and if you don't have any filter, then your router or your link, the peering link, can be a transit for the other peer on the IX. Okay, so filtering is very important. Okay. Egress traffic. What is egress traffic? Egress traffic means packet, how it leaves from your network. So from your network, how packets are going outside. So that is what we define as egress traffic. Packet is going out. So when the packet is going out, or the egress traffic, to ensure the egress traffic, what you need? You need the route availability, right? It means when traffic need to go out, where or which destination traffic would like to go, right? That destination has to be available on your router's routing table, right? So when your upstream will make that route available to you and you accept that route into your routing table, right? Then the traffic can go out from your network. If I bring a very simple analogy about egress traffic, if I need to go to your home tonight for a dinner, right? If I am the packet, need to go to your home for a dinner, what you need to do, you advertise your home address to me. So when you advertise your home address to me in this direction, incoming direction, then as a traffic I can go outbound direction, right? So traffic flow and routing flow are opposite to each other. So to ensure the egress traffic, it means traffic going out, the destination prefix has to be in your routing table, right? So that's what we call route availability. Okay. Then ingress traffic, right? Ingress traffic means traffic from your customer or other network coming into your network, right? Traffic coming into your network. So your network is the destination. So your network address has to be available to them. So traffic or ingress traffic when coming inside your network address, you need to make it available for the others, right? So when it goes to you, then on the other side, if they accept it, then the traffic originated from that particular network can come inside my network. So that's what we call ingress traffic. There is a question from Redon again. For egress, default route will work too if destination prefix is not even. Yeah, that's true. I mean, routing table. I mean, we have to have a routing information in my router, right, to send the traffic across. So for that information of the destination, it can be as a default route or it can be as a specific route. That is obviously, understandable. Make sense? Okay. So yeah, so ensure the ingress traffic means traffic coming outside inside your network. You need to make your route available for the outside network. So it's other way, right? You have to advertise your route first, then traffic can come inside your network. Okay. Autonomous system, AS. What is an autonomous system? An autonomous system is a collection of network with the same routing policy under the single administrative control and routing protocol. Okay, so this is how we define an autonomous system. Say in this diagram we have 5 routers. All those 5 routers, they are internally connected. All those 5 routers, they are internally connected. So those all routers, they are administered or managed by a single administrative control, and they share the same routing policy, right? So this is how we define an autonomous system. If I need to be specific, say if we have got 2 networks, in one network we have got 5 routers, other network we have got another 5 routers, right? So if all 5 plus 5, 10 routers, if they don't share, like 5 routers in this side and the 5 routers on the other side, if they don't share routing information in the same IGP, we can consider them separate AS. So all 5 routers within AS 100, if they share their routing information into same IGP, and other 5 routers, they don't share their information with this group of routers, then we can consider them as a separate AS. Or there is another question. Will not work, can please suggest any input? What is the question? Yeah, please confirm default route will not work. Okay, then can. Ingress when using default or. Well, you're always Okay, listen. The analogy that I gave you, if I need to go to your home for dinner tonight, you need to send your address to me, right? So your address to me, that or how to go to your home, this information I need to have in my routing table, right? And that particular information you can send me as a default route, or you can send me as a specific route. So when I'm saying ingress and egress traffic, what I mean, for ingress traffic coming inside my network, I need to make my route available to the others, right? So when I need to make route available to the others, if it goes to my upstream, their policy with their downstream not to send any specific route, right? So they still can make my route available to them. How? They can send a default route to them. So the default route, client traffic can come to the transit router, operator, and from the transit operator with a specific route, it can come to me, right? But the prefix has to be available either as a default or as a specific. Make sense, everyone? As I said, you advertise your prefix, right, to your upstream, and then if your upstream they advertise prefix to their downstream, they can advertise your specific one, or they can advertise as a default to their downstream. If they advertise the default, through the default, that prefix can come up to the transit ISP, and from there with a specific match it can come to the downstream to me. So that's what the purpose, but the prefix has to be there as a default or as a specific. All right, so an autonomous system is a collection of network with the same routing policy. Okay, and as I said, to be specific, the definition of autonomous system, normally what we do in a single network, if all the routers they share the same IGP, we can consider them as a single AS. When the routing will happen from one network to the other network through BGP, then that is the demarcation, and this is where we have two separate AS. Okay. All right, some definitions. Neighbor. What is a neighbor? Definition of neighbor you can consider from a bigger point of view, or from a bus size point of view, or from an AS point of view. Okay. Say for example, if AS10 connected to AS20, right, and then AS20 connected to AS30. Then AS10 and 20 they consider as a neighbor AS, right? That's what we call neighboring AS. And if you see the two neighboring AS, not necessarily all the routers of AS10 connected to all the routers with AS20, right? Probably only a single router of AS10 is connected to a single router of AS20. So when those two routers they connect to different AAs, those two routers are considered neighboring routers, right? And from the bigger point of view, those two AAs are considered as a neighboring AAs. All right. Announcement. What is announcement? Announcement means when any prefix an AAs is forwarding to the other AAs, that's what we call announcement, right? Or a single router is sending it to the other router, we call it announcement, right? Announcement not necessarily mean that particular router or that particular router they own the prefix. They can announce someone else's prefix if the policy permits. Okay. Except means when the prefix announcement comes, right, that router whom the prefix announcement came, they are accepting that announcement into their routers. That's what we call accept, right? Originate. Oh, there is a question. Please confirm, in multi-hop neighboring are route exchanged directly? Well, when we do multi-hop, eBGP multi-hop, that's what you mean? Yeah, definitely. Like, in eBGP multi-hop, they exchange route, in between those router, but it's going via several next hop. Your next hop reachability has to be there. When next hop reachability are there from your router to the other router whom you're exchanging the route, yeah, they're exchanging directly. Is that okay? All right, so now we will define originate. What is originate? Originating means in your router, right? So when you add a network statement, by adding a network statement, you are advertising a prefix, right, to your neighbor. That's what we mean origination. So you are sending the prefix advertisement from that router to the next router, right? And when you send or you originate that prefix, it goes to the next router, and from there that router can announce it to the next router. It can be the same concept when we compare with AS, right? One AS can originate the prefix, right? And from that AS, when it goes to the next AS, if the policy permit, they can forward it to the other AS. That's what we call announcement. There's another question. Does transit have to know the route which I am exchanging with my... Sorry, your question, does the transit have to know the route which I am exchanging with my far neighbor? Can you please sort of clarify your question? What do you mean by far neighbors? Does transit router have to know the route which I am exchanging with my far neighbors? Well, we have future slides, so don't worry. So when we'll go slowly, like in the future slide, it will explain clearly what is the relation with the transit router, right? So what happened if you advertise any route, it goes to the transit path or your upstream router, right? They can advertise or they can announce the prefix to their downstream, right? Or they can send them, depending on the routing policy with their downstream, right? Your transit provider's downstream. If they only send the default route, still the reachabilities are there from that downstream up to the transit routers, and then from there we'll have a specific routing. But in your question, what you said, does transit router have to know the route which I am exchanging with my far neighbor? Okay. Are you considering, like, the synchronization rule of BGP? But that is far sort of advanced stuff that we haven't covered it yet. That is the synchronization rule, but that is different things. So we'll explain later on. Okay. All right. So then we'll see peers. What is peer? So peer means when two routers, they build a relationship to exchange routing information, we consider them as a peer, right? So peering is a very common terminology that we use in the BGP routing, right? So in BGP routing, all those routers whom we build neighbor relationship, we consider them as a peer, and when the peering relationship has been built, right, they can exchange routing information. All right. Okay, so routing flow and packet flow. As I said, you have AS1 connected to AS2, right? So from AS1 to AS2, when they exchange traffic, what are the preconditions, as I have already explained? For networks, any networks that we have in AS1 and AS2, if they would like to communicate, right, networks from AS1 and AS2, then what is the precondition? precondition is AS1 must announce to AS2. So networks that AS1 has got, they must announce it to AS2, right? So when it goes to AS2, which is we call routing flow, right? Routing flow in this direction. So when it goes to him, he must accept it. The announcement, he must accept it, right? If his policy permits, then he will accept the route. And when he accepts that route will be in his BGP table or like, you know, yeah, it's mostly in BGP table. And from there, he will select the best path, and that goes to his routing table. So when the prefixes are there, then what is the next process? Next process is AS2 also advertise his own route to AS1. When it goes to AS1, AS1 must accept it. When AS1 accepts it, it also goes to his BGP table. So that's why in internet, since it's two-way direction, so both the networks are in both AS routers, right? So when that match are there, then the traffic can come in, right? So when the routing advertisement went in this way and other way, right, then the traffic can come exactly in opposite direction. So that's what we call routing flow and packet flow. So in routing flow and packet flow, if we filter outgoing routing information, right, then eventually what we are achieving, we are inhibiting traffic flow inbound. It means I am not sending my home address to you, right? Since my home address to you I am not sending, so that you as a traffic cannot come on the other way around. So this is what we normally call filtering your traffic on the control plane, right? So for example, if you are running this online web class, if only selected people can join in this web class, how we can restrict that? Say in the world, if we advertise that date and time and even password to everyone in the world, right? So everyone knows something is happening now in evening office, so they all can jump into it. But we can't allow everyone, right? So we have to then add a filter. How? So only the registered person can join in. So these things we can do it in a better way. How? What was the point? Like if only those registered people are allowed to join in this presentation, why not we only send that address or advertisement to those registered people, not everyone, right? So that everyone doesn't know, they cannot come. So that's a better way of managing your traffic if you don't advertise your prefix. And when I'm saying filtering outbound, it's just sort of filtering your routing advertisement. It no way is a replacement of your usual traffic filter. It's just an alternate way to manage your routing effectively. Okay. All right, let's move on. Routing flow and packet flow with multiple AS. So when we have a multiple AS, say for example AS16, AS8, right? AS16 is connected to AS8, then AS8 is connected to AS34 and AS1 on the other side, and AS1 and 34s are directly connected, right? So in this situation, if we have a network N1 in AS1, to send traffic to N16 in AS16, what are the precondition, right? Precondition is AS16, this AS, traffic from this AS would like to go to this OS. The precondition is AS16 must originate his prefix, which is N16, and announce it to AS8, because AS8 is directly connected. Now when the prefix goes to AS8, what AS8 will do? AS8 will or AS8 need to cooperate, right, with AS1. So if AS8 announce that traffic advertisement that he received at the first place from AS16, if he advertise or if he announce that prefix to him, then the path will be built in here, right? So if he only advertise that prefix to him, then only one path will be built in here, right? How the other path can be built? Then AS8 need to forward that prefix advertisement to AS34 as well, and then AS34 will forward it to AS1, right? So when that N16 advertisement goes this way and this way, then both the path will be built. That is the precondition. Right? When advertisement goes via this way, then traffic can come via this way. So this is how the AS path normally built in BGP. Make sense? As I said, to build multiple paths, we need to send or we need to advertise the prefix through all the possible paths. If the physical connectivities are there, but the prefix advertisement don't traverse via those physical connectivity, path will not be built. Okay. So that's what we call routing policy. So the routing policy actually used to control the traffic flow in and out of an ISP network. So for example, a single ISP can take a decision how the path will be built or not. So to take the decision, like if I go back to the previous diagram, right? If they would like to build the path in between, sort of AS1, AS8 and AS34, right? They can filters based on individual route. So when they do filter based on individual route, that's what we call normally in routing scenario called prefix filtering, right? So individual prefix need to be permitted, or if you consider the prefix filtering, all the prefix individually need to be permitted or denied. That's what we call prefix filtering. The second option is you can build your filter based on prefix originated from a specific AS, right? So any specific AS, when they will sort of originate the prefix will be allowed or denied. You can make filtering, or you can make your routing policy based on that as well, right? So this sort of filtering can give you a scalability, right? Scaling option, because in a single autonomous system, you can have a number of prefixes, right? Some prefixes are originated, some prefixes are getting transit via. So in that case, if the policy look into individual prefixes, then it will be a scalability issues, because in a bigger environment, normally an ISP, they deal with so many prefixes, right? Or you can make it in a more specific way, any prefix traversing via a single ASs. This concept is normally applicable in the transit environment. If there is any operators, they are providing transit, right? So the transit operators who is providing transit, their upstream can do filtering based on AS traversing via that transit upstream. Like if you see tier 1, tier 2 and tier 3 architecture in internet, normally tier 3 ISPs, they do filtering based on prefixes, right? So whoever the customers connected to them, they allow their prefix individually. Then from that tier 3, when the prefix has been advertised to tier 2 normally they don't look into individual prefix normally, but what they do, they check whether the prefix is coming via that tier 3 who is already a customer of tier 2, right? If the prefix coming via that AS, probably they'll allow it, right? So this type of policy is applicable on the transit environment. And in a bigger environment, you can even group prefix using some community, some tagging, right? So based on the tag also, you can build your filtering. So that's what we call routing policy implementation based on different options. Routing policy limitations. So there are some limitations that we have. It's not limitations. So this is how routing policy actually works. If you see this diagram, we have AS99 in this side, and then on the other side we have red AS and green AS, and in the middle we have an internet cloud. So if you want to exchange data from red AS to AS99 via the red link, right? The condition is AS99 should advertise their prefix via the red link, right? They need to advertise the prefix via the red link. When the prefix comes via the red link, then traffic can go via the red link as well, right? And if you need to exchange traffic from AS99 to the green AS via the green link, then it has to be advertised via the green link as well. So that's what the routing policy, this is how it works. If you see in a complicated environment, If you have got an AS in the middle on the internet, then when AS99 advertise the prefix to AS22, and that is advertised via the red link. But if AS22 they don't advertise the prefix via the red link, then the path all the way along the red link will not be established. If AS22 don't agree to send or advertise that prefix via the red link, if they send it via the green link, then from this side the traffic from red link will come via the green link. So AS22 must cooperate. Not only AS22, all the AS along the path, they must cooperate. Otherwise, this policy cannot be implemented. Okay. Okay, there is a question. If AS99 is using default route for egress traffic, okay, can flow for red and green traffic will be achievable? Okay. Default route in AS99 is not advertising. AS99 is advertising its own prefix, right? So AS99 has got some prefix that he must advertise. Default prefix is prefix coming from outside. So from outside, if the prefix or default prefix comes via green link and another default prefix comes via green link, then there will be a problem, right? Because in BGP, your BGP will win the best default. You can't control it. But if you want to control it, you have to use some specific routing. Make sense? And we have already discussed, right? What are the disadvantages of default routing? What are the advantages of default routing? If you need destination specific routing, in this case, for example, destination specific routing, right? You can't do it using default route. Okay. Routing protocols. The routing protocols that we have are actually grouped into two classes: IGP or Interior Gateway Protocol, EGP or Exterior Gateway Protocol. IGP is a class where all those routers, right, belongs to same AS. Within the AS, when all the routers they exchange the routing information, we call it IGP class, right? So for example, OSPF, ASes, right, are an example of IGP class of routing protocol. EGP class, so for example, BGP is an example of EGP class, Exterior Gateway Protocol. When you are doing routing in between two AS, then you can use EGP class, right? So far as an option, we have got only one protocol, which is BGP as an EGP. But IGP, we have a number of options. What we advertise in IGP, to make or to design a scalable network, right? Normally, we advertise our infrastructure prefix in IGP. Infrastructure means obviously we have got our loopback and point-to-point link. All those infrastructure prefixes, loopback and point-to-point, normally we advertise into IGP, because as we know in IGP, if we have got like so many prefixes, so for example, in internet we have got 500,000 prefix, no way your IGP can scale. Your convergence time will never reach the convergence, right? In such a big topology database. So normally what we do, we use IGP to ensure the next hop reachability for the BGP. Okay, and we advertise only the loopback and point-to-point prefixes in IGP, so that this is how we can keep our IGP small. Only the infrastructure prefixes are in IGP, but all the external prefixes either coming from downstream customer or upstream internet that we send via BGP. So if we have got our POP routers, from the POP router with the customer router, we use eBGP, and our gateway router with the upstream we route eBGP, right? And within the infrastructure of the service provider, we use iBGP to carry the external prefixes. So that's what normally we do, right? To minimize the IGP table growth, and we can ensure IGP convergence. So why do we need IGP? As I have already explained, so in an ISP environment, to sort of create a hierarchical network, to scale in a bigger environment, right, we only advertise our infrastructure prefix in IGP, and we try to minimize the IGP size so that our network can grow. EGP or exterior gateway protocol. So as I said, exterior gateway protocol is sort of a BGP and is an example. So BGP is normally used to decouple your AS from external AS, right? So this is how, when there is an issue happening on the external AS, BGP can easily withdraw the route, right? And BGP can deal with so many prefixes because BGP works on layer 4, right? And BGP convergence works in a different way than IGP convergence. IGP, they all build the topology table and from there they select the best path, but BGP, they select the best path in a different way using BGP attributes, right? So that's why in BGP, right, so even though you have a number of prefixes, still BGP can scale with hundreds of thousands of prefixes. Okay, so why we need an EGP? As I said, to define the administrative boundary, right, to connect separate AS, and we have got if we have got multiple AS connected among different networks, BGP is the right protocol to build path and implement the policy, right? And using BGP policy is very sort of easy or flexible to sort of manipulate the attribute and influence BGP best path selection criteria. BGP can just implement whatever is your business policy. Comparison between interior and exterior protocol. Interior, they automatically discover the neighbor, and there are some exceptional case in OSPF, but yeah, they normally discover the neighbors automatically. But exterior protocol, we have to configure the neighbors, right? In BGP, in interior protocol, normally you trust your IGP routes, right? And in BGP, normally connecting with the external routers, right? So trust has to be there. Yep, and what else? Normally IGP or interior protocol carry the infrastructure prefixes, and exterior protocol, they carry customer prefix and internet prefixes. Okay. Main objective of IGP, when we design it, make it small, short and sweet, and EGP, they can scale, they can carry lots of prefixes from internet. That's why in internet we can still run internet using 500,000 plus prefixes. If you see the hierarchy of your design, just a simplified diagram. You can use BGP to connect your peers in IX. You can use static or BGP to connect your customer. Within your network, you can use either OSPF or ASes to carry the next hop of BGP. And then among all infrastructure router, you can run iBGP to carry the external prefixes. And then in your upstream, you can use BGP to connect to your transit or upstream ISPs. So that's what sort of a hierarchical diagram how you can plan for your routing. It's a very simplified diagram. Okay. So AD value, administrative distance, since in a single router we are running more than one routing protocol, right? Sometimes we have got static, sometimes we have got OSPF, sometimes we have got BGP. So mostly like static, OSPF and BGP, three protocols are running, sometimes connected as well. So when you have got more than one option as a routing protocol, definitely router need to know which routing protocol's route should we install in the routing table. So that's why AD value or administrative distance values are there. So if you see this hierarchical number, right? So OSPF has got AD value of 110, eBGP has got an AD value of 20, right? And iBGP has got an AD value of 200. So who has got the lower number or lower AD value? Highly preferred paths, or higher the probability to install that path into the routing table. Alright, so this is the end of the presentation for today. So now if we have any question, you can take more questions. And also, as I said, we have given you an URL here for the SurveyMonkey feedback. I'll try to write the URL for you in here. Okay, surveymonkey.com. Oops. Yes, ePNIC 20131120EL3. Yes, that's the URL to sort of complete your feedback. So when you complete your feedback from this URL, it will redirect you to an FTP site. From that FTP site, you can download the presentation material that we used today. Okay. Oh, there's a question. Why we only have lecture about AS and not area? Well, this is what we call routing basic, right? We have got another module called WSPF. We have got another module called BGP. We have got another module called BGP attributes, right? So in one hour, we are not going to cover everything, right? So just keep your eye on in our training website, and we have got a number of modules that we are covering. So when we discuss about WSPF, basic WSPF, we are not going into very detail of WSPF areas in basic WSPF. We just define and show you the areas, right? But in future we will have advanced WSPF. Then we can explain the topology database of WSPF and all those LSA types, all right? And also about AS numbers. There is another question. Oh, okay, so thanks. Okay, is there any other question that we have? If no question, then thank you very much. Thank you to everyone to attend our session today. As I said, we do web class e-learning every Wednesday. Just keep your eye on in our training website, training.epnic.net. And if you are interested to attend any other advanced topic, just make yourself available and we can discuss. So